differentiation, but only for science stream. Before we proceed further, that day we have seen inverse of some standard trigonometric functions. Also we saw the second exercise 1.2 up to some extent. Today what we are going to do over here is we will have a glance on the formula of page number 20 and how it happens. Like for example, I will give you some hints over here. We had y equal to sine inverse x. So dy by dx we wrote 1 upon under root 1 minus x square. In future, you may get composite functions in this case, like y is equal to sine inverse f of x. Then in that case, you have to apply same formula which we have used, 1 minus f of x the whole square, and then outside we take f dash of x. So suppose if it is cos inverse x, then here it was minus sine. So here also it will be minus sine, but the thing remains the same. Means what I want to say, instead of sine inverse x, it can be a sine inverse log of x. In that case, you have to write 1 upon under root 1 minus log x the whole, and then into derivative of log x, which is 1 by x. So that way you have to do it for cos, tan. For example, for tan also we did. If y is equal to tan inverse of x, then we wrote dy by dx is 1 upon 1 plus x square. So instead of that, if you have y is equal to tan inverse f of x, then under such situation dy by dx will be 1 upon 1 plus fx the whole square and into f dash of x. So like that you have to do. So this one table is clear. The table number is 1.2.6 where all such information is given. Let us see the part. Actually this is not a new thing. We have already done this in class 11 about various inverse formulae of trigonometric functions. Like we have done this one, sine inverse of sine theta or sine inverse of sine x. Whenever such type of situation is there, whatever is the value of the angle, that is your RHS. Like for example, if you have sine inverse of sine pi by 2, then your answer will be for this pi by 2. In this way, now question arises, why we are going to see again this which we have done in class 11. The reason behind it is such kind of angles are simple, but in the exercise instead of angle there will be functions, there will be expressions, algebraic expressions, many more things will be there. All those are to be solved and you have to bring it in the form sine inverse of sine of some function, and then the answer whatever comes out, that you have to differentiate at the end. No need to differentiate sine inverse of sine theta or sine x. Directly reach up to the final step where you are free from sine inverse and sine. There should be no trigonometric term over there supporting the angle. One more thing, instead of this angle, there can be a function, another function. So in that case, you have to handle carefully in that case. Now, along with this, complementary angles are there. Very interesting thing they have given. Last time only we have seen cos of theta is sine pi by 2 minus theta, or vice versa, sine theta is cos pi by 2 minus theta. Then tan theta is cot of pi by 2 minus theta, and cot theta is tan of pi by 2 minus theta, and so on. Sec theta is cosec of pi by 2 minus theta, cosec theta is sec of pi by 2 minus theta, and many more are there. Why to do that? Suppose if you have sine inverse of cos theta. Then you can't apply this formula and you can't write that this is equal to theta. Sine inverse should have trigonometric ratio of sine. Cos inverse should have trigonometric ratio of cos. Tan inverse should have trigonometric ratio of tan. That is why I have to do some formulation work and somehow I have to bring it to the trigonometric ratio of sine. That is why I am going to use complementary angles. Cos theta, I can write this as sine inverse of cos can be written as sine of pi by 2 minus theta. Now if you look, the inverse has same trigonometric ratio, and in that case whatever is the angle, that will be your answer, pi by 2 minus theta. Now this answer, dear students, you have to differentiate. So pi by 2 will become, it's a constant, so it's a 0. Minus remains as it is, and you have to differentiate theta with respect to theta. So answer will be minus 2 in that case. We'll see some problems, then you will understand it in a better way. But this is what I was trying to explain to you. Also, suppose if you have of this kind, tan inverse of cot theta. So you can do tan inverse of tan pi by 2 minus theta. And the answer comes out to be pi by 2 minus theta. This you have to differentiate with respect to theta. And then it can be anything. It's not theta, it will be x or anything else. If I was in your place, I would have thought, this is okay, complementary angles I can understand. What if the trigonometric ratio is besides complementary angle? Like sine inverse with tan or tan inverse with sine, then what is to be done? Answer is very easy. There is nothing in this world which doesn't have a solution somewhere. Answer is very easy. Answer is like, again you have to revise from class 11 the chapter trigonometric functions. There they have given list of double angle, single angle, half angle, triple angle, and trigonometric identities of these half angle, double angle, and triple angle. That you have to put it here, you will get the answer. It's so easy, but you should have knowledge. I suggest today itself, it will take hardly half an hour or 1 hour maximum. Open your 11th standard mathematics textbook, take a chart paper, and on that write down all the formulas of trigonometry which will be helpful for us in this chapter as well as integration. So I hope these two tables are clear to you. Now, besides that, what else is there? Let us see. Dear students, you are aware sine of x is 1 upon cosec be sin inverse of 1 by x. Then sec inverse of x will be cos inverse of 1 by x. Cos inverse of x will be sec inverse of 1 by x. Tan inverse of x will be cot inverse of 1 by x. Cot inverse of x will be tan inverse of 1 by x and so on. So this will be the formula. I hope that you have understood this part also of the table. And now the last part, which is very important, interesting. Three formulae given here. Sin inverse of x plus cos inverse of x is pi by 2. Tan inverse of x plus cos inverse of x is equal to pi by 2. Sec inverse of x plus cosec inverse of x is again equal to pi by 2. And these two are special cases, very interesting. Two separate angles, if they are there, tan inverse of x plus tan inverse of y, so it will contribute to tan inverse of x plus y. Dear students, it is exactly like that. Tan of a plus tan of b. You might have done in that case. Tan of a plus tan of b. So the same concept they have used. Also you can have minus tan inverse of x. Only the sign changes here also. This is equal to tan inverse x minus y upon 1 plus. So this is the concept of tan inverse, sin inverse and sec inverse, and then addition of two different angles with their inverse. Substitution table we will see it later on, not required at this moment. Let us proceed further. Towards the part of the exercise, which is there. That day we were solving a question, and it was question number 3. Today we are going to see using derivative proof that first one is tan inverse of x equal to, it's a new function. You can also take it as g also. So that I will just give my. If I differentiate this, I call this as equation. Differentiating equation 1 with respect to x. So that will become 1 upon 1 plus x square. Let us take LHS itself. Minus 1 upon plus minus of 1 upon 1 plus. Plus into minus is minus. You have to see this. So this comes out to be 0. So suppose f of 0, in this case I take it as k, where x of mine is 0. Now question arises, which angles of, to take tan inverse of 0, x becomes 0 in this case. Tan 0 is 0. Even you can take 0 radian. And cot inverse of 0, and you are aware of that, it is pi by 2 radian. So LHS will be 0 plus pi by 2, which is equal to pi by 2, and this is equal to our RHS. So in this way, we get the answer LHS is equal to RHS. So I hope, dear student, this question is clear to you. One more they have given. Sec inverse x plus cosec inverse x. So that also can be done on the same method. Let us proceed towards question 6, where they are asking us to differentiate with respect to x. Y equal to tan inverse log of x. In the beginning itself I told you, today when I started with the inverse, I gave you the explanation of that table which has composite functions. Now here it is not tan inverse of x, here it is tan inverse of fx. Just for beginning I am telling you once again the repetition part of it. Tan inverse of fx will be 1 upon 1 plus fx the whole square into f dash of x. So differentiating y with respect to x. So dy by dx will be d by dx of tan inverse log of x. So it will become 1 upon into derivative of log x. You are aware? So it will become dy by dx is equal to 1 upon 1 plus log x the whole square. Derivative of log x is. So you can't go further beyond this. This will be your final answer. Then next, let us see. cosec inverse e raised to minus x. Now, on page number 20, table 1.2.6, it says d by dx of cosec inverse f of x is minus 1 upon fx under root fx square minus 1 into f dash of x. This is the given. So my fx is e raised to minus x. So differentiating y with respect to x, dy by dx will be d by dx of cosec inverse e raised to minus x, which will be minus 1 upon, now my fx is e raised to minus x, I will write here e raised to minus x, into under root of e raised to minus x the whole square minus 1 into derivative of e raised to minus x. So this comes out to be minus 1 upon e raised to minus x. This becomes e raised to minus 2x minus 1 derivative of e raised to x minus x is e raised to minus x, and again derivative of minus x. So minus minus will become plus. So finally dy by dx is equal to plus 1 upon e raised to minus x and under root and 1 into e raised to minus x. So that e raised to minus x and this e raised to minus x gets cancelled, and final answer comes out to be e raised to minus 2x minus 1. Further again we can do it by taking the inverse of it. So I hope you have understood this. For today